Okay, so hopefully everybody now has out their worksheet 25 and their calculators. And I'm going to start, I'm going to do a few of these just to get you, help you out. So the first one that I'm going to look at is number 2. 12 picks equals how many glebs? Now for part 1, all of these, you're being told that it's their exact qualities, exact amounts. So that means that you don't have to worry about sig figs. They have an infinite number of sig figs. They're not measured numbers. You know that everything's exact. So just all these answers, I'm pretty sure, are full numbers. So you don't have to do sig figs right now. So number 2 says 12 picks equals how many glebs? And if we look at the equivalences on the top, there's no one thing that will go from picks to glebs. So we have to figure it out. So you always put the number that you're given first. It starts out on top. And now we need to convert picks to something else. So I see that 4 picks equals 1 jab. So I need to cancel out the picks. So I'm going to put 4 picks on the bottom and 1 jab on top. And now I know that I can convert these jabs to snubs, and then I have an equivalence that will get me from snubs to glebs, and then I'll be done. So we're going to go, so we've canceled out our picks and we just have jabs left. So to go from jabs to snubs, I see that 5 jabs equals 2 snubs. So jabs goes on bottom to cancel out. So 5 jabs, 2 snubs. So jabs are canceled out. And then now I want to go from glebs to snubs. So I know that 5 glebs equals 1 snub. So 1 snub, 5 glebs. So my snubs cancel out, and that means all my units have canceled out except for glebs. Which means unless I make a math error, I've probably got the right answer. Anytime you're doing any kind of unit conversions, if all your units cancel out correctly, chances are you got the right answer. It's a pretty good idea. Okay, so luckily for us, we can do this math in our heads. 5s cancel out, 12 and 4 reduces to 3, so I have 3 times 2, 6 glebs. And this is exactly 6, not 6.0 or 6.00. But exactly 6. Okay, so now we'll do one of the metric conversion questions, and I'm going to do number 9. So this question says, how many picograms are in 0.0876 centigrams? In this case, you might be tempted to convert directly from centigrams to picograms, but the best way to do these kinds of unit conversions with the SI prefixes is to convert back to the root. So the centi prefix means that there are 100 centigrams in 1 gram. And if I looked at the SI prefix sheet, that would also tell me that. So we have 100 centigrams equals 1 gram. And then to go from grams to picograms, 1 gram equals 1 times 10 to the 12 picograms. And if you're not sure how many it is, you could look that up. So I look at the sheet, 1 pico, the pico means 10 to the 12. Okay, so I can use these conversions to convert centigrams to picograms. So I have 0.0876 centigrams. So now I need to cancel out centigrams, so 100 centigrams on the bottom, 1 gram on top. Now I need to convert from grams to picograms. So I have 1 gram on bottom, 1 times 10 to the 12th picograms on top. And this equals 8.76 times 10 to the 8th picograms. I'm just checking sig figs. How many significant figures should I have in this answer? 3. That's right. So we have 3 to start with. 1, 2, 3. These don't count. These are exact quantities, 100 centigrams per gram, 10 to the 12 picograms per gram. So these are exact. So 3 significant figures, 8.76. Are there any questions on those so far?
Wait, why would you have to be the 8?
Because, well, your calculator will tell you this, but this is 8 to the negative, this would be 10 to the negative 2. Oh, you're right. Is that right?
Okay.
That's right. Okay. Yeah. Okay, and this is 10 to the negative 2, so that's 10 to the negative 4 times 10 to the 12th, so that's 10 to the 8th. Okay. So I'm going to do some more from the back on density, but first let's talk about what density means. Okay, so density is a word that you've probably heard before, I hope. I want you to take 10 seconds and just think to yourself, what does density mean? And secondly, what does it mean for something to be more dense than something else? So just think in your mind what that might mean. It is, right? Yeah. Okay, so can somebody tell me what they talked about? What do you think density is? Anybody want to tell me what you might think density is? I just want to know what you think. Someone, I heard you all talking about it. Vernon.
The amount of mass per cubic centimeter?
Yes, that is a measure of density. That is a definition of density. What does it mean in words? How dense. How dense it is. Yes, density means how dense something is. Okay, so how dense something is, density is mass over volume. So it's how heavy it is. It's a ratio, so which is why it's really hard to describe. So it's a ratio of the mass, how heavy it is, over how much space it takes, the volume. So something that's really dense is heavy, but it takes up only a little bit of space. It's something like lead. You pick up just a little piece of lead, and it's really heavy. It's like, what is this? So something that's not very dense, it might take up a lot of space and have a small mass. So like styrofoam. You could pick up a huge piece of styrofoam. It doesn't weigh anything, right? So styrofoam is not very dense. Something that's more dense is going to sink. So if you had 2 liquids and one was more dense than the other, the denser one would sink to the bottom. Something like oil and water. Water is more dense than oil, so water sinks and oil floats. Now, you might think if it's more dense, that means it's harder, it's more solid. And while solids usually are more dense than liquids, there are some pretty notable exceptions, like mercury. That's a liquid, but it's really dense. You can float on mercury. And ice. That's a good one. We see that all the time. Ice floats in water, right? And it's because ice is less dense than liquid water. And the reason that is because if you have the same amount, the same mass of water, when you freeze it, the water molecules sort of relax and it gets bigger. The ice as a whole is bigger. So if you have the same mass and a bigger volume, the density goes down. So that's why maybe you're like cooking and you pour some soup into your favorite glass jar and then you stick it in the freezer, fill it too full, and it breaks. Does that happen to anybody? It's definitely happened to me. It's because that water expanded when it froze, and you ran out of space. It's no good. So, little tip, always leave a little extra room when you're putting your soup in the freezer. Okay, so maybe you're on the test and you're looking at this and you're like, crap, how do I figure out density again? I can't remember. So there's this little trick I learned from Mrs. DePlatis, and she learned this from Mrs. Rocheflow, who is another science teacher here. And you just gotta think, we love density. So just, if you get stuck, draw a little heart on your paper. I know there's some people in this class who like to draw hearts on papers. So draw a heart on your paper and draw a line through it. And what do you know? We've got an M and a V. So density is mass over volume. So if you get stuck, draw a heart. Maybe that'll help you. Density, it can be abbreviated as D. So that's really common. If you get to college, you might, in some sciences, we will abbreviate density. Instead of D, we start to use Greek letters. So density is also sometimes abbreviated as rho. So it looks like a P, lowercase p, but it's a Greek letter called rho. So I might do this on occasion because I forget. So if you see this, don't freak out. It just means D, density. Okay. So now let's do some fun stuff. So I've got these 5 beautifully colored liquids. And what I'd like to do is stack them up in a jar, make sort of a rainbow jar. But in order to do that, I need the most dense liquid to be on the bottom and the least dense liquid to be on top so that they all stay in their proper layers. So I need you guys to help me figure out what order I need to add these liquids to the jar. So I happen to have a list of how much mass they have and what volume they would take up. So we need to calculate what their density is in order to see which one will go first. The standard unit that we usually use for density is grams per milliliter or grams per cubic centimeter. 1 cubic centimeter, so that's like a cube with each side is 1 centimeter long, is the same thing as 1 milliliter. And sometimes cubic centimeter, especially in medicine, is also called a cc. So these things are all the same thing. But for something like this where I need to compare the density, it's going to be best if we can convert all of them to the same units, which would be grams per milliliter. Okay. So I have these 5 liquids with different colors. So I need you all to have out your calculators so that you can help me and we can calculate these densities quickly. So the orange liquid has a mass of 30.5 grams and takes up the space of 49.0 milliliters. The red liquid, if I had 12.3 grams of it, would take up 10.2 milliliters. My yellow liquid is 16.8 grams, takes up 19.9 milliliters. My blue liquid, 13.7 grams in 17.3 milliliters. And lastly, my green, 25.2 grams in 25.2 milliliters. Okay, so let's calculate the orange one first. So density is going to be the mass over the volume. So 30.5 grams over 49.0 milliliters. How many significant figures is this answer going to have? 3. Okay, so what's the density? Somebody calculate for me?
62.
0.622 grams per milliliter.
Thank you, Michaela. 0.622 grams per milliliter. Okay. So, what's the density of the red liquid?
1.205 split significantly.
Okay, 1.2058 is what we said?
Yeah.
So, how would we round this so that we had the right number of significant figures? How many sig figs do we want? 3. Good, because we have 3 here and 3 here. So what would this round to?
1.21.
1.21. Does everybody see that? So we want 3 sig figs. This was 0.58, so 5 or above we need to round up. So 1.21 grams per milliliter. Okay, so the yellow liquid, what's the density of this guy? 0.844. Okay. The blue?
0.792.
0.792. And the green?
1.
Good, everybody can do that. Is it just 1? Do I need anything else?
1.00.
Good, 1.00. And what are the units? Grams per milliliter. Okay. So, which liquid am I going to add to the bottle first?
Yellow. Or, my bad, orange.
Red.
Okay, I want to add the most dense liquid first,
So
which is this guy. Sorry, it should draw nice lines. Okay, so this is first. And then what's next? Green. Good. And then yellow. And then blue. And then orange. All right. Be a good chemist. Add my safety. Wear my safety goggles. You don't know what these are. These are mysterious liquids. They might be harmful. Does this work for you?
Yeah, but can you turn the light off?
Yes, thank you. Sorry.
Yeah.
Okay, so I've got this red liquid. Any guesses as to what this might be? It is corn syrup. That Mrs. DeBlot is dyed red. Okay. Okay, so what was next? Green. All right. Okay. So, can everybody see this? Sort of got 2 layers. Oh, no. Got 2 layers right now. Okay. Next is yellow. Let's see if I can do this better than I did in first grade. Much better.
Probably vegetable. Vegetable oil is actually the packet.
He did dye it though. Okay, so now it's blue, right? Great, this is the one that I messed up. First grade, so let's see if I can do it nicely. tell you when we're done. I just didn't add it very well. So it got all mixed up and then it got stuck down here. Really good. Okay, so I'll hold it up, but if you look at it from eye level, it's like these perfect layers. So good. So the most dense is going to be the bottom, and the least dense is at the top. So let me hold this up. Everybody can see it? I'll see it. I don't know. Does this help? The weight? Can you see it? All the layers? Pretty cool.
Flip it upside down.
What?
Flip it upside down.
Monday. We'll do it Monday. So this, if we don't disturb it, it should stay pretty well like this.
So what are all the
Okay, so the bottom layer was corn syrup. The green with the 1 gram per milliliter is water. So it's pretty easy to calculate density with water. It's pretty nice because it's 1 gram per milliliter. It's pretty much the only density that I've memorized. And then the yellow and the blue are oils, and I can't remember which is which. We have a mineral oil and a vegetable oil. And then the top layer is alcohol. And you can kind of see, I don't know if you could see, there's like these orange flakes in here. And that's the dye. It's not very soluble in alcohol, so it's trying to come out. But these should stay if I don't knock it over or shake it up. Oh, and one more thing. I keep forgetting this. So I got this bouncy ball. And I've already lost it. Okay. Let's see. If I added it to this, where do you think it would end up?
green?
Green? Is that the class consensus? Green?
Blue.
Yellow.
Blue? Yellow?
Green.
Nobody thinks it's gonna be down here?
Oh, red. Red.
Okay, let's see. So it looks to me like it's right between yellow and blue. So what do you think the density of this ball is then? Like approximately?
Probably like 0.8, like 0.8.
Yeah, so it's got to be between 0.792 and 0.844. So it's going to be around 0.8. Yeah, it's kind of cool. So just because it's solid doesn't mean it's more dense. Although this, I guess it's solid, but it's probably full of air. So let's look back at worksheet 25 and do some density examples from the back. And then I've got worksheet 26, which is more density. So, looking at number 13, number 13 says, I have 46.9 cubic centimeters of zinc, and I want to know what that is in grams. If I look at this table up here, I can see that the density of zinc equals 7.14 grams per cubic centimeter. So this is just a simple unit conversion. You can use this density as a conversion factor. So I start with what's given, so 46.9 cubic centimeters. So what goes on the bottom here? I'm trying to cancel out cubic centimeters, so what might go down here? Cubic centimeters. Right? Because these would cancel. So then what do you think would go up here? Any ideas? Well, if I look at the problem, this is given to me, the density, 7.14 grams per cubic centimeter. So I can just put that right up here, 7.14 grams over cubic centimeters, right? Because grams per cubic centimeter, that's a fraction. That's the same thing as grams over cubic centimeter. So this right here is the density of zinc. So it's a really nice way to just convert from volume to mass by plugging in the density. So I've canceled out my cubic centimeters and I'm left with grams. And how many significant figures will I have in this answer? I hear you. 3. Good. So, because I got 3 here and 3 here, so my answer is going to be 335 grams of zinc. Okay. So now let's look at doing these conversions going the other way. So number 14, I know that I have 150 grams of silicon, and I want to know how many cubic centimeters that is. So if I look up at the table, the density of silicon equals 2.33 grams per cubic centimeter. So, okay, got my 150 grams. What's going to go on the bottom of this fraction? Grams. Did everybody see that? Because we're trying to get rid of the grams and get cubic centimeters. So that means I've got to have cubic centimeters on the top and grams on the bottom. So I'm just going to put the density on the bottom, 2.33 grams per cubic centimeter. Okay, so don't think that it always has to go on top. It's really just dictated by the units. So my grams are going to cancel out. And how many significant figures in this answer? 3. So this is going to be 64.4 centimeters cubed. Okay, any questions on that? Alright. So let's do some more practice. So let's do a few to get started. Okay, so if we look at number 2, it's asking us a very similar question to what we did here. So what we need to do is compare the densities of these 4 liquids, right? So we're given liquids A, B, C, and D, and we're trying to figure out what would be the most dense that we would add first, and then the least dense, which we would add last. So in order to compare the densities, all those densities need to be in the same units. And so our best bet is going to be converting all of them to grams per milliliter. So let's look at problem C and see how we would do this kind of unit conversion. So now we're combining what we know about density with the conversions that we did yesterday. So this problem says that I have 3.56 teaspoons. So that's volume, 3.56 teaspoons. And the mass is 0.490 ounces. So the first thing is I need to set up the density. So density, remember, so this is C, equals mass over volume. So I need this on top and this on the bottom. That's the very first thing. So 0.49 ounces over 3.56 teaspoons. But ounces per teaspoon, again, it's not a very useful unit of density, so let's convert this to grams per milliliter. Now, we're gonna have to convert both of these, right? We've gotta convert ounces to grams and teaspoons to milliliters. And you can start with either one, it doesn't matter. But I'm gonna start with ounces. So, if I look at the equalities at the top of the page, I see that, let's see, 1 gram equals 0.0353 ounces. So what goes on the bottom here?
Ounces.
What unit goes on the bottom?
Ounces.
Ounces. Good. Needs to cancel out. And the top is grams. So 1 gram equals 0.0353 ounces. So it cancels out my ounces, I have grams, so that's good. And now I need to get from teaspoons to milliliters, and I happen to have the same conversion right here. So I've got 1 teaspoon on top and 4.9289 milliliters on the bottom. So my teaspoons have canceled out. And now I just have to calculate. Now how many significant figures am I going to have in my answer?
3.
3. Something that I will often do is look at the problem, maybe do the setup, and then just write a little note to myself how many sig figs I want. You don't have to do this, it's just something that works for me. So I know 3 sig figs, okay, if I can do the problem, I'm ready to go. So to put this in your calculator, you can do it in any order, it doesn't matter. If it's on the top, you're going to multiply. If it's on the bottom, you're going to divide. So the 1, you don't have to do that because so many times 1 or divided by 1, that's the same thing, right? So I'm just going to type in 0.49 divided by 3.56 divided by 0.0353 divided by 4.9289. Now everybody should do this because sometimes I punch in numbers wrong in my calculator. I did it twice during first period. So everybody should do this so that we can make sure that we're getting the right answers. So I get 0.79108. Did you guys get that number too? Okay, so what would this number be with 3 significant figures?
0.791.
Good, so it's 0.791. And what are the units?
Grams per milliliter.
Grams per milliliter. All right, good. Now on a test, let's say you did all this, but somehow you punched the number wrong and you got, I don't know, 4.53 or something. If all of this was correct and you got the wrong number, you'll just lose a little bit of points. If on the test, all you wrote was this, and you didn't show me anything else, you'll probably lose more points. The most important thing is to show all your work, because then if you make a mistake, it's easy to find it. So show your work. It's absolutely the best habit. I cannot stress that enough. Don't think, oh, I can do this in my head. It's easy. You're setting yourself up for failure when it gets more difficult. We are going to use unit conversions for the rest of the year. You're going to use them for the rest of your life if you do science anyway, or baking or anything. So get in the habit of just laying out all the steps. It will make even the most difficult problems so much easier. Cannot stress that enough. Okay. So now I'm just going to let you guys work, unless there are questions I can help out. There's one that you guys want to see. Alex?
How would you convert liters to milliliters?
Say that again?
How would you convert liters to milliliters?
How would you convert liters to milliliters? Good question. So that's something that you should know, probably. But if you don't remember, milli is one of those SI prefixes. So by definition, there are 1,000 milliliters in 1 liter. Just like there are 1,000 milligrams in 1 gram. So you should know that. Any other questions? No. Okay, so why don't you guys take some time to work on this, and if you have questions, let me know and I'll kind of circulate. Does that sound good?
guys doing?